This is your time to ask about. So, as you look at your homework from Friday, does anybody have a question to start off with us? Anybody have a question, Milana? Start us off today. Okay. Four? Sure, let's start off with question 4, guys. Question 4. Right here, there's a lot going on with question 4. If you have your calculators out, it might be good to have your calculators out as well. Okay, on question 4. Now, on this question, really on a good chunk of that front side there, this is beginning parts of giving you guys part of the circle, going through and just finding all the different missing measures. Are those measures representing angles? Are they representing arcs? And then are those measures representing what type of an angle? Are they representing an inscribed angle, or are they representing a central angle? Because as we saw on Friday, that some of those those inscribed angles are what? Half of the central arc, half of the central arc. Everything else is right. All right. So as you look at number 4 here, well, the only thing we got to start off with is 60 and 80, right? And that 60 and 80 individually, they're not, 60 and 80 individually are not going to an angle. 60 by itself does not go to an angle. What do I mean by that? 60 right here, okay, 60 is this arc right here. And if I trace it backwards, 60 goes only to part of angle 4. 80 right here only goes to part of angle 4. So what you should notice here is that 60 and 80 together, what's 60 plus 80 give me? 140 degrees. That 60 plus 80, that these two together, what are those going all back to? That's going all back to all of angle 4. So all of 80 and 60 together, which is 140, trace it back to that angle, that is going to angle 4. Now, that angle 4, what do we classify angle 4 on Friday? Is that a central or an inscribed angle? Show me just a hair of life. Inscribed, thank you. It's an inscribed angle because the vertex is on the circle. Okay, now what do we then say about inscribed angles? Inscribed angles are what from the arc? Double, same, or half? Those are the 3 outputs. They're half, right. To go from the arc backwards to the inscribed angle, they are half. So if we take half of 140, that's where we're getting that 70 degrees from. As you find the measure of the angle, I would encourage you to put it in the picture. And that's like I did there, okay? We've got one. Bless you. Okay, now where's the next part coming from? Okay, that's 140 degrees we just found. Now, right here, I've got the other part of that circle. 360 degrees. 360 degrees minus 140 is 220. Now, the reason why I highlighted that 220 is because that 220 goes right back to angle 2. So that angle 2 is sitting on a circle, and angle 2 also represents an inscribed angle. And what is, again, the inscribed angle relationship? Half of 220 gives you that 110 right there. So you got to keep knowing, is that inscribed or a central angle? Inscribed is half of the arc. So that's why I labeled that one as 110. Okay, we've got those two things going. Lastly, where am I getting these 90s from? These 90s are coming from the quiet one. Quiet one is that diameter. The diameter is never something going to be very loud in the problem. It's always there, but it's never going to be very loud. The diameter is right here. And what do we know about the diameter? What does the diameter do to a circle? The diameter cuts it in half. So half of the 360 is 180. And just as we've been tracing things back to an angle, that 180 traces back to where? Angle 3. As we trace back to angle 3, well, what's half of 180 again? Because that's another inscribed angle. Half of angle 3, sorry, half of 180 is 90 degrees. That's where I'm getting that 90. And I did the same thing on angle 4. There's that diameter. Here's that 180. Half of 180 is going right back to angle 1. There's that 90 as well. Okay. Diameters are the quiet ones you got to pay attention on, because they're going to be the ones that help you look at those 90 degrees on those. Okay. All right, that's a good question. I don't expect you to have these mastered yet. They come with some practice. Okay. Keep going. There's one. What's the next question somebody's got? Do that assignment. What you guys got next? It's up to you. Other questions you guys got? Think through things. Wait, Grace? Yeah. Barely? Or no? Seems to be the thing to do. 6? Sure. So get number 6, says Jaden. Alright, let's get 6 there. Number 6, all about your vocab. That picture is pretty darn involved. There's a lot of things going on. And again, there could be more than one answer off of these. I just gave you a sample answer on those. So next thing I'm looking for is you guys naming those again correctly. All right. With that radius, you got to have the O and then one of the points. OF, OB, OE, OC, OD. Those are all possibilities off of there. All right. That should be the quick one, and a diameter. EB is one, or what's another diameter up there? FC is a possibility as well, but those are your only 2 options for your diameter. Now, after that, most of the rest of that, it's all new stuff. Okay. Okay. Minor arc. Minor arc, 2 points. Don't give me 3 points, just give me 2 points. On that minor arc, I said CE. Here's C, here's E. Clearly it's less than 180. It's always going to be. Okay, when you say 2 points for that minor arc, we always go the shortest route. Okay, CE works, CG, AB is a minor arc. That's a poor choice. Let's say FE, actually. FE is another minor arc. There's more than one option on those minor arcs. I said FE. Why did I make an E? Okay. Chord, AG, I said. Now go find A, go find G. There's A, there's G. That's a chord, AG. Now, I use my, should just be a single line on that one. I don't know why I made a double line. Another chord that's up there, you could have said chord FD as an option. Segment FD. Those are all chords. Okay, now you're getting some major arcs. Major arcs better be 3 points. Make sure it's also bigger than a semicircle, bigger than 180. Now I suggested BFC, which is more than a semicircle, the direction it tells you to go. BFC. Another example of a major arc, GBF. That's a little bit larger than a semicircle. There's another one. Now again, GBF is what I said, but don't use 4. 3 is what we use for the major. Point of tangency, that's where that circle or that line is just kind of coming in and kissing. That circle is just one distinct point. And that's that point B. That line appears to be tangent. which is going to borrow with this dude right here, the tangent. Now that tangent, I said is line AH. You could have said line AB. They mean the same thing. Just pick 2 points on that tangent line. They're the same thing. Okay. Going up at the top, semicircle. Semicircle, remember we said that last week. If you just said FC, I don't know what semicircle you're referring to. You got to tell me a point in between F and C to go which direction for what semicircle. And when I said FBC right here, that tells me this left semicircle. Okay, central angle. Where's that vertex got to be? It's got to be at the center. And one central angle I said was F to O to E. That's one option. Another central angle you could have said was EOD. Where's O at? It's at the vertex. It's at the center. That works. More than one option off of these. Now, I'm a little bit more specific. It's got to be obtuse. An obtuse central angle. COE is an obtuse central angle. That's more than 180. Or sorry, more than 90. COE. Last one there are, secant AG. Go find secant, and I don't know where that G came from. AG right here. AG is right there. That's your only option for the secant. Secant is a line, and there's only one line that intersects that circle at 2 points. That's what a secant does. Line intersects at the circle at 2 points. Okay. There's no other options for a secant. It's all about the vocab, and then we use the vocab. We'll use it this week and into next week as well, and after Thanksgiving break. All right, keep going. Anybody else find another example, another question that you had if we ran through that one? Going once, going twice. Okay, make sure your name's on it. Then throw it into the basket. And as you come back, on number 2 is where I think issues with naming these correctly kind of were at. All right, real quick, give me a pair of alternate interiors on that first one. What's the pair of alternate interiors, somebody? What would you guys say? 3 and what?
4.
Oh.
4 and 5.
4 and 5 would be it.
Yeah.
3 and 6. If you said 3 and 4, 3 and 4 is actually adjacents, and those are making a linear pair. So 3 and 4 would be a linear pair instead. Somebody, give me a pair of correspondings real quick. What's a pair of correspondings? 4 and 8, says Tyler. Yeah, 4 and 8 correspondings, same side, one interior, one exterior, 4 and 8. Okay. 4 and 8, 1 and 5. Other pair is what? 2 and 6 or 3 and 7? Okay. Now, the next group, number 2, the reason why that one maybe might have had some scratching going on there is with those 3 points. And that's where a lot of our problems usually come into, so let's take a look. What I would encourage you to do if you had an issue with that is labeling you're drawing these pictures and just labeling the 2 angles that you need to talk about, ignoring everything else. So what I mean by that is XVU. Here it is, trace it out, XVU, and that angle is right there, isn't it? So we're talking about this angle, same side exterior now. So that's the angle, it's exterior, same side of the transversal. That means it has to be this angle there, right? XVU. Sure. XVU with same side exterior. With that, and then as you trace it out, okay? XVU. And when you trace that out, now we go ahead and can name it. Boom, 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 boom. QSR, QSR, QSR. So angle you should have said was what? QSR. And then like you said, we can always reverse it. RSQ would have also been correct. But S has to be that vertex inside of there. That was the only possibility. RSQ or QSR, we can reverse that same angle. So again, if parallel lines and transversals, my experience has been that's usually one of our weak points on things. I would encourage you to sketch out the basic information like I have here. Ignore all that extra noise. Same thing here. Go find VSR. Where's VSR at? Trace it out. Where's VSR? VSR, VSR. Okay, VSR is right here. Where's it in my picture? It's right here. Okay, that makes sense. It's interior. Now you want to be alternate interior. Now alternate interiors, we said, cannot be adjacent because that means they are linear pairs. And that means the only option could be right there. And now trace out that letter, or that angle, I mean. And looking at that angle right here. We're at this angle right here. And what is that name of that angle? Angle what? WVS or SVW. Okay? And that's the only option off that. Okay? So see what you did there, but that was my first hour's issue off that. Now, the next one, check all that apply. Now, as we check all that apply off of this, my first hour, again, kind of struggle a little bit off that. My encouragement to you is, this is what I always kind of do, throw in a dummy number. What do I mean by a dummy number? This is an acute angle, right? Give me an acute number. What's a nice acute number? 60 degrees. If that's 60 degrees, let's go base everything off of 60. If that's 60, that's 60, right? And then this is going to be what? 120 and 120, right? Okay. Now, if that's 60 and that's 120, hopefully you realize you've done enough work through last week. If that's 120, then that's going to be same side supplementary. That's going to be 60, right? And then that's 60 and that's 120. The reason why I'm doing this is I want to match up everything that's congruent to WVX. Once I know what I'm looking at for angles, I can just quickly see, hey, which ones are 60s or which ones are 120s. So find WVX up there. Where's WVX? Trace it out. Where's WVX? Which ones are 120s? For me, I can quickly see which ones are 120s. I can check them off. So let's go see which is 120s. Where's TSV at? TSV, give me a sec. TSV, is that a 120? Is TSV a 120? Let me write you that. All right. TSV. Right here is TSV. I'm looking for 120. Is TSV a 120 then? Yes, it is. I'm getting a check because it's congruent to that 120 that I wanted. QST, where's Q? ST at? QST is right here. Is that a 120? No, so I'm not checking that. RSQ, where's RSQ at? RSQ, is that 120? Yes, it is. Did you check that? UVQ, okay, it's clearly a vertical angle, which is 120. Cool. And XST, where's XST? XST, that's a 120, and did you have all four of those checked? Hopefully you did. Again, that's my encouragement. If you're not 100% sure if you're congruent or supplementary, I always throw in dummy angles, okay? All right, flip it, let's take a look. And then as we take a look on that back side there, alrighty. First thing that jumps out to me is this pair right here. What do we know about that pair right there? It's adjacent, making a supplementary. What do we say about those? What do we call those guys? No. They are a linear pair. Okay, they're a linear pair.
So it must mean x equals 55,
Well, eventually, yeah, it'll be x equals 55, or yeah, eventually it would be x equals, not, the x doesn't be 55. This angle would be 55, and 15x minus 5 equals 55, is the other way to say that. Now solve it out. X equals, so 120, subtract 120, x, 15x equals 60. And what do we get for x, somebody? X is 4. So x is actually going to turn out to be 4. So if I plug in that angle there, Tyler, and I do 15 times 4 minus 5, now together that angle is 55. But what I want to know is individually, what is that x right there got to be? X has to be 4 in order to get that 55 angle. Okay, that's what I was looking for.
But what measure?
The measure is 55 degrees, but what does the variable x have to be in order to get that 55 degrees there? That's what I was looking for. All right, and then that last one, what was that y? Now on that y, I was noticing, walking around, these two dudes here together. And then that's 7y plus 27, and then that's, maybe I looked up that other one wrong on yours. I was looking at, just thinking about that. That these two here are setting these two things equal to one another, right? So 7y plus, whoops, 7y plus 27 equals 125. That should have been the equation. Why am I setting those two things equal to one another? They're alternates and exteriors. And what do we know about alternate exteriors? They are congruent. So subtract it out. 27 divided by 7. I think it's 14, wasn't it? Y is 14. So y is 14. Okay. So y turns out to be 14 off of that one. Maybe you had that one, or was it 180? I don't remember on that one at this point. I wasn't sure. Okay, so that right there is just a little bit of preview of what's happening on your guys' quiz for, what is that, Thursday then, okay, with some work with parallel lines and transversals. Okay, so let's go ahead and let's take a look at a couple things in your book. Let's turn to page 211, everybody. Page 211. Let's get your books out. Let's keep talking about that vocabulary. We're going to do just a couple examples today, and then we'll finish up tomorrow. Page 211. Page 211. Page 211 is all about that vocabulary again. Page 211 here. And I want to take a look at some of our vocabulary that we've been using. Page 211. Okay, on 211, what I want you to do is on that first one, letter B. Let's do letter B. Draw an example of what's being stated there. Vertical angles are congruent. If you were to sketch out a picture, what would that picture look like to get across to somebody? Vertical angles being congruent. What would that picture look like for vertical angles congruent? Take 30 seconds to go. What does vertical angles being congruent look like? Go, go, go. Sketching out that picture. Vertical angles congruent. I just picturing everybody. Okay. I'm not saying ballpark. I'm forcing myself today.
Which one are we doing?
B. Vertical angles are congruent. Sketching out a picture to show me something about vertical angles being congruent. We're going to do a couple of these and then we'll pause it for today. That's right. Tomorrow, hopefully, a little livelier crowd. Okay, with vertical angles are congruent. what are we doing on vertical angles and congruent? Just throwing up Mr. George's gang signs, right? All right. Now, just because we got those up there, show me which angles you're talking about to signify you have vertical angles. Which two angles up there are telling me we have verticals. Okay. Show me with the angle markings, or you can put your numbered angles up there and then tell me you have 1 and 2 are representing our vertical angles. Tyler?
Would it be alright to assign them to like variables that say
Yeah, you could say X and Y or something like that.
and X degrees equals Y degrees?
Yeah, it's the same thing. So you could also say like, yeah, 1 and 2, and then right below that, 1 is equal to 2, X and Y. Yep, here's a few different, whoops, I said 2 and I wrote a 1, didn't I? Try this again. 2. Yes, that would be another way to do that. Show me something that would try to imply these are vertical angles and they are congruent. All right, let's do one more here at the bottom, E and F. I'm gonna give you a minute. Try to get across to somebody E and F. Alternate interior angles are congruent and corresponding angles are congruent. What would be an example of you sketching out that? And we're gonna be finishing off with this last one, E and F. E and F right there. I'm gonna give you a quick minute on E and F right there. E and F there, guys. Quick minute on that. And about what we just talked about, let's go and wrap one up. Are you getting across that? Turn to your buddy. Take a quick 2 minutes. Did you get that across? Sketching out that picture as you get across corresponding. Maybe Grace did. Maybe Andrea or Jason there. I'm not a tea person. Sweet tea? Nope.
Not even like the really sweet tea that gives you sugar.
Nope. Not a tea person. That's right. I have one for sure.
That would be sugar water.
All right, let's roll through this. Let's finish up, guys. If you're trying to show me an example of something, alternate interior angles, all I was looking for is, I was walking through and seeing a few examples, something like that, right? Parallel lines, first make sure you got me parallel lines shown. Some type of transversal. Those are ultra interiors, right? And then for correspondings, same idea. But where's an example of correspondings at? Aren't those correspondings? That's all I was looking for. Okay. All right, we'll do some more work with that tomorrow, this week, in preparation